So picture this. You are like an hour deep into working on a complex project inside a web application.
Oh, I know exactly where this is going.
Right. I mean, you might be editing this massive video timeline or mapping out a really convoluted flowchart, or maybe just filling out one of those endless multi-page government tax forms.
The absolute worst.
Totally.
Yeah.
And you are completely in the zone, but then tragedy strikes.
Let me guess, a trackpad accident.
Exactly. Your finger brushes the trackpad the wrong way,
Yeah.
or, you accidentally hit a keyboard shortcut that triggers a refresh. The screen just goes blank for a split second.
And when it comes back.
Everything is gone. Every
Yeah.
single edit, every custom setting just completely wiped out. You just sit there staring at the default screen, feeling like your own computer just betrayed you.
It is a universally painful experience. And, well, it happens because historically we've all been conditioned to accept a very specific mental model of the web, that browsers are essentially just document viewers.
Right.
They fetch a page from a server, they render it on your screen, and the second you leave or refresh, they just suffer from total amnesia.
Total amnesia.
Yeah, they forget everything they just showed you because our only job was to display it, not to actually remember it.
Which is incredibly frustrating when you're trying to get actual work done.
Yeah.
But here's the thing. Browsers don't actually have to suffer from that amnesia anymore. Okay, let's unpack this. Our deep dive today focuses on some really fascinating insights from Aaron Rose over at tech-reader.blog.
It's a great piece.
It really is. Specifically, his article on IndexedDB The Local Database that makes browser apps stateful. So our mission today is to completely shatter the illusion that your web browser is just a glorified window looking at a remote server.
I love that framing.
Thanks. We're going to uncover a hidden, incredibly powerful memory bank that's built right into the software you are using to listen to this right now. It's a system that turns the browser into a fully self-contained application platform.
And it's a system that flies completely under the radar for a lot of people. I mean, when developers realize they need a browser to remember something, the immediate default is often a tool called local storage.
Right, I've heard of that one.
Yeah, which has its place. If you want a website to remember whether you prefer dark mode or light mode, local storage is perfect. But its mechanics are, well, super limited. It's just a synchronous key value store that can essentially only hold simple strings of text.
So if we're thinking about how that actually works, local storage is essentially like having a small whiteboard sitting right next to your monitor.
That's a good way to look at it.
You can scribble a quick note on it, like user prefers dark mode, but you wouldn't try to transcribe your entire company's accounting ledger onto that little whiteboard.
No, definitely not.
It just doesn't have the capacity. And because you mentioned it's synchronous, writing a massive amount of data to it would physically freeze up your browser until the writing was totally finished, right?
Precisely the problem. If you try to dump massive amounts of data into a synchronous system, the main thread of your browser just locks up. You can't scroll, you can't click, the whole interface just freezes.
Oh, wow.
Yeah. And that is where the source material draws a very hard line. IndexedDB is not just a bigger version of that whiteboard. It is the browser's true heavy-duty database. We are talking about an enterprise-grade NoSQL object database that is natively built into every single modern browser.
Let's break down that term NoSQL object database for a second, because that sounds like some heavy enterprise jargon.
It really does.
Traditional SQL databases are very rigid, right? They're like massive spreadsheets. You have to define the columns ahead of time, name, date, file size, and every piece of data has to fit perfectly into those little boxes.
Yeah, exactly. But a NoSQL object database operates completely differently.
Okay, how so?
Well, it's radically more flexible. With a NoSQL object database like IndexedDB, you don't have to force your data into rigid rows and columns. If you have a complex, deeply nested JavaScript object, say, like a user profile that contains an array of recent projects, which in turn contains custom metadata and interface settings.
That's a ton of very data.
It is, but you just hand that entire object to the database as is. It swallows it whole and stores it natively. You don't have to translate it or break it apart.
Oh, I see. That flexibility makes total sense for complex web applications. And importantly, it's fully asynchronous.
Exactly.
So going back to that freezing issue, asynchronous means the browser essentially hands the save operation off to a background process.
Yeah, that's right.
It tells the database, hey, go save this massive video timeline and, just tap me on the shoulder when you're done. Meanwhile, the user can keep scrolling and clicking without a single stutter in the interface.
It keeps the user interface buttery smooth. And on top of that, it is fully persistent across sessions. The data survives page reloads, it survives you closing the browser, and it even survives a complete reboot of your machine.
We really?
Yeah, it's a permanent record living right on your local hard drive.
Which brings up a really interesting contradiction here.
Okay, what's that?
Well, if I'm building a robust application, the traditional wisdom is that you rely on a back-end server, right? You spin up a database in the cloud, and you save everything there. If IndexedDB is living entirely on my local machine, aren't we losing the power of the cloud? Like, why wouldn't a developer just save this data to a normal server database like they always have?
What's fascinating here is that the answer really comes down to the unforgiving physics of latency.
The physics of latency.
Yeah, think about the physical journey your data takes when you save to the cloud. Your browser has to package that data, send it over your local Wi-Fi, route it through your internet service provider, beam it across the country to a server farm.
Oh, man.
Right. Wait for that server to process it, save it, and then send a confirmation all the way back. Even on a gigabit fiber connection, that takes milliseconds. Often it takes whole seconds.
And if you're on an airplane or like a spotty train connection, that round trip just fails entirely.
Exactly. You end up staring at that little spinning wheel of death in the middle of your screen, totally paralyzed.
Yeah, we've all been there.
But by leveraging IndexedDB, reading and writing data involves absolutely zero network hops. You are eliminating the middleman entirely.
Zero hops.
Zero. The app feels instantaneously responsive because the data is sitting on the exact same physical solid-state drive as the browser itself. There's no backend required to maintain the state of the application. It's instant, local, and functions completely offline.
So you're basically buying back whole seconds of load time and completely removing the internet connection as a point of failure.
Precisely.
But that local storage still needs to be reliable, right? The source material emphasizes that IndexedDB is transactional and ACID compliant. Those are concepts usually reserved for banking software or massive server architectures.
They are. And it is crucial to understand how they function mechanically to really appreciate what the browser is actually doing. ACID is an acronym. Atomicity, consistency, isolation, durability.
That's quite a mouthful.
It is, yeah. But mechanically, it means the database operates on an all-or-nothing principle to prevent corruption.
Okay, so give me an example. If I'm saving a massive project file and my laptop battery suddenly dies halfway through the save process.
The worst timing.
Right. Does an ACID-compliant database guarantee that when I reboot, I won't be left with a half-written, corrupted file that just crashes the whole app?
That is exactly the core mechanism. If the operation is interrupted, the database literally rolls back the transaction. It acts as if the save never even started, reverting to the last known perfect state.
Oh, wow.
Yeah, you either get a 100% successful save or no save at all.
Yeah.
You never get a corrupted, half-finished mutation. That level of professional enterprise reliability is living silently inside your browser, managing your data right now.
That completely reframes the whole concept of what a browser is capable of. But, it also introduces a new problem.
What's that?
A heavy-duty, asynchronous, ACD-compliant database sounds incredibly complex to actually program. If a system is this powerful, it usually comes with a steep learning curve.
True.
How does a developer actually orchestrate all of this without creating just a tangled mess of code?
It can be intimidating, which is why establishing a clear mental model is so important. The architecture of IndexedDB revolves around three foundational pillars. If you grasp how these three interact, the entire system becomes predictable.
Okay, lay them out for me.
First, you have the database itself. Second, you have object stores. And third, you have transactions.
Okay, so what does this all mean? Let's move away from the simple whiteboard and think of IndexedDB as a highly secure digital vault.
I like where this is going.
The database is the vault itself. It's the outer shell that contains everything for a specific application. Inside that vault, you have the object stores. Because this is a NoSQL system without strict columns and rows, these object stores are like distinct safe deposit boxes.
Right.
You can put a stack of text documents in one box, a collection of complex 3D rendering settings in another, and high-resolution images in a third. The only rule is that every item inside a box needs a unique label or a key so the database can find it later.
That captures the structure perfectly. And the third pillar, transactions, acts as the security protocol for accessing those boxes.
How so?
Well, if a background process in your web app opens a safe deposit box to update a file, the transaction places an exclusive lock on that box.
Oh, okay.
If you have a second tab open for the same web app and it tries to modify that same file, the transaction forces it to wait in line. It ensures that data is read and written in a safe, orderly sequence, completely preventing two processes from colliding and overwriting each other simultaneously.
That makes the daily operation of the database really clear. But, apps evolve. Features get added all the time. What happens a year from now when the developers decide they need to completely restructure those safe deposit boxes?
Yeah, that's a big question.
Because if this data lives exclusively on my local machine, a developer can't just log into a central server and fix the database schema for me.
If we connect this to the bigger picture, that is perhaps the most fascinating mechanical detail of the entire system. It's the versioned upgrade model.
The version upgrade model.
Right. IndexedDB enforces strict versioning to protect your local data from being accidentally wiped out by a bad app update. When a web application asks the browser to open the database, it doesn't just say, open the vault.
What does it say?
It says, open the vault, and I expect it to be version 1.
Okay, so what happens when the developer releases an update that requires new object stores and they change their code to ask for version 2?
The browser detects the mismatch between the version 1 vault on your hard drive and the version 2 request from the new code.
Right.
At that exact moment, the browser halts normal operations. It triggers a highly specific, isolated event called an upgrade handler. Think of it as a frozen state.
So everything just pauses.
Exactly. While frozen, the developer's migration script runs, creating the new safe deposit boxes, safely moving your old data into the new structures. And only when that migration finishes successfully does the browser unfreeze the database and upgrade it to version 2.
So a developer can't just accidentally break the database structure on a whim. They are forced to be deliberate. The browser actively gatekeeps the structure, ensuring that your historical data is safely migrated before any new application code is allowed to touch it.
Yeah, it's a brilliant safety net.
It really is a perfect safety net for local-first architecture. But navigating that architecture hasn't always been pretty, right? The source material notes a specific historical wrinkle. The native API for IndexedDB relies heavily on something called callbacks.
Yes, and understanding callbacks is key to understanding why developers used to really shy away from this technology.
Why is that?
Because IndexedDB is asynchronous, you can't just ask for data and move to the next line of code. You have to tell the browser what to do after the data is eventually found. Historically, you did this by passing a callback into the request.
Which creates a mechanical nightmare if you need to do several things in a row.
Yeah.
You end up with a structure where you say, go open the vault, and when you are done, run this next function to find the box, and when that is done, run this function to open the box.
Yes, exactly.
The code just starts indenting further and further to the right, creating this sideways pyramid that developers affectionately refer to as callback hell.
It becomes nearly impossible to read and debug. If an error occurs deep inside that pyramid, tracking it down is an absolute nightmare.
Oh, I bet.
But the ecosystem evolved. Modern JavaScript uses a mechanism called promises to solve this. Instead of nesting functions inside each other, a promise acts like a digital voucher.
A digital voucher, okay.
When you ask IndexedDB for a file, it instantly hands you back a promise ticket that says, I don't have the data yet, but hold on to this voucher and I will alert you the millisecond it is ready.
Wow, that flattens the code out entirely. You can just read it top to bottom. Await the vault opening, await the box opening, await the data retrieval.
Exactly. And to make it even easier, developers use tiny, lightweight wrapper libraries, like one simply called idb, which translates all those old, messy callbacks into clean, modern promises.
That totally modernizes the interaction. It makes it really accessible for average developers to use this powerhouse database.
And once you have that clean, predictable interaction, developers can start utilizing IndexedDB for much more than just saving text and preferences. They can start pushing the boundaries of what a web application can actually touch.
Which leads to what the source material identifies as the ultimate capability of the system.
Right.
If a web app truly wants to feel indistinguishable from a native desktop application, it needs to interact with the raw files on your computer's hard drive.
Yes, absolutely.
Here's where it gets really interesting. Because saving my complex UI layout is one thing, but if I'm building a robust video editor in the browser, I need to access gigabytes of raw video files stored in a folder on my desktop. Now, modern browsers have the File System Access API, right? Which allows a web app to ask for permission to open a local folder.
It does, but historically it suffered from the exact amnesia we discussed earlier.
Oh, really?
Yeah, you could grant a web app permission to open your video projects folder, and you could edit your files perfectly. But the second you close the tab, the browser security sandbox wiped that permission from memory.
So next time you open the app,
You had to click Open Folder, navigate through your entire hard drive, find the folder, and click Allow Access all over again.
that creates immense friction. It constantly reminds you that you were just using a temporary web page, not a real application.
Exactly. But this is where IndexedDB deploys its secret power move. The NoSQL structure doesn't just store text objects. IndexedDB is capable of natively storing raw file handles.
Wait, really? File handles?
Yes. Specifically, it can store objects called file system file handle and file system directory handle. It is the architectural glue that bridges the gap between temporary web access and a persistent user experience.
That's huge. So it can permanently save the exact digital handle to your local folder right inside the database. It remembers the precise location of your files across sessions, surviving reboots and reloads.
Precisely.
Okay, I need to pause here because I've got to play devil's advocate. The security implications of this sound terrifying at first glance.
I completely understand why you'd say that.
If I understand the mechanics, does this mean a website can permanently save a skeleton key to the private files on my hard drive? Because if I visit a tool online and it silently remembers how to tunnel back into my documents folder without me knowing, that is a catastrophic security risk.
That reaction is exactly why the mechanics of the browser sandbox are so important to understand here. Storing a file handle in IndexedDB is absolutely not the same as storing a skeleton key.
Okay, so what is it then?
The handle itself has no inherent power to bypass security. Think of the handle as a highly precise GPS coordinate. The web application saves that coordinate in IndexedDB, so it never forgets exactly where your folder is located.
Okay, so the app knows where the house is, but it doesn't necessarily have the key to open the front door.
Exactly.
How does that play out when I reload the page the next day?
Well, when you reload the app, it pulls that GPS coordinate, the file handle, out of IndexedDB. It points directly at your local folder. But the browser itself still acts as the uncompromising security guard at the gate.
Ah, I see.
Before the web app is allowed to look inside that folder or modify any files, it must hand that coordinate to the browser and request permission. The browser then throws up a native prompt to the user. This application wants to read and write to this specific folder again. Do you grant permission?
So the security check is never bypassed. The user still has to explicitly click yes every single time they start a new session.
Precisely. But the friction is gone. Instead of forcing you to manually dig through your C drive, into the user's folder, into documents, into projects, just to find the right directory.
It just knows.
Right. The application instantly surfaces the exact folder you were working on yesterday and asks for a one-click confirmation to resume. The browser maintains absolute security, but the user experience feels completely seamless. It's exactly like opening a recent projects menu in a traditional desktop application.
It is respecting the user's strict security boundaries while simultaneously respecting their time and their workflow.
Perfectly said.
When you synthesize all these mechanics, the persistent offline state, the asynchronous performance that prevents UI freezing, the ACD-compliant reliability, and the ability to persist local file handles, you realize this isn't just a clever set of browser tricks.
No, not at all.
It represents a fundamental paradigm shift in software engineering. The source material calls this the local first revolution.
It is a revolution because it directly challenges the dominant software model of the last 15 years. I mean, we have been living in a cloud-centric universe where the server is the ultimate source of truth.
Right, everything lives in the cloud.
In that model, your powerful laptop is basically reduced to a dumb terminal, a piece of glass that only works when it can successfully beg a distant server for data. Local first architecture flips that dynamic entirely.
And the database layer, powered by IndexedDB, is the foundational pillar of this local first model. It's the dividing line between a clever HTML document and a true resilient application.
Absolutely.
If we look at the practical reality of this, imagine you are on a long-haul flight across the Atlantic. You have absolutely zero internet connection.
Classic dead zone.
Right. You open your laptop and you launch your most complex data-heavy work application in the browser.
Under the old model, you would just get a blank screen or that little pixelated dinosaur game.
Yep. But in a local first application powered by IndexedDB, the app loads instantly. The entire database is living on your solid-state drive, your recent file handles are preserved, your custom UI layouts are intact, and you can spend the next 6 hours making thousands of complex offline edits.
And the application never stutters because it isn't waiting on a network ping.
Exactly. Then, when you finally land and reconnect to a network, the application can quietly sync those changes in the background to a cloud server for backup or collaboration. But the cloud is no longer the bottleneck for your productivity. The primary source of truth, the engine driving your immediate experience, is entirely local.
And that shift in power requires more than just local storage.
Wow. What else does it need?
Well, the source material astutely points out that if you are going to process massive data sets locally, you need incredible performance. You can't freeze the UI while crunching numbers.
Right, you'd be back to square one.
That is where the next pillars of local first come in. Web workers and the Streams API, which allow heavy computational lifting to happen in the background. When developers combine those performance APIs with the massive storage capabilities of IndexedDB, the web browser essentially transforms into an operating system of its own.
It gives ownership of the computing experience right back to the user.
It really does.
So, to pull all of these threads together for everyone listening, the next time you are deep into a web app and your internet connection drops or you accidentally hit refresh and you brace yourself for that visceral sinking feeling of losing all your work.
But instead, the page reloads and everything is flawlessly preserved.
Exactly. Every text box, every complex setting, every local file connection is exactly where you left it. When that happens, you now know the mechanics behind the magic. You have a hidden, version-controlled, NoSQL database called IndexedDB to thank.
The silent, asynchronous workhorse.
The workhorse sitting in the background, making sure your browser never forgets a thing.
It fundamentally rewrites our expectations of what web software is capable of doing.
It really does.
And this raises an important question. If we really examine the trajectory of these local first capabilities, it leaves us with a profound thought about the future of technology.
What's that?
If our web browsers are now equipped with native-level ACD-compliant databases that remember everything, and if they can process gigabytes of local files instantly without ever needing an internet connection,
Yeah.
what does the future actually hold for the multi-billion-dollar cloud hosting industry? We have spent the last 2 decades building massive, centralized server farms to hold our data and run our applications. But what happens to that industry when developers fully realize that the most powerful, lowest latency back-end server an application could ever possibly need is actually just the user's own machine?